Without taking much time, I would like to now introduce our first project topic and team for today's presentations. Just a quick note, after each presentation, we will open the floor for questions. So do have them ready. You can raise your hand and we will call out your names and you can unmute yourselves and ask. Starting with project 1, the topic is Mini Bach Harmonizer. Let Bach back you up. A simple web application inspired by Google's first AI-based doodle. The Mini Bach Harmonizer is a tool for musicians and music enthusiasts alike. The team members are Ajinkya, Bhaskar, Shibani, and Shrish. Over to you guys.
Yeah, thank you, Bhavna, for providing us this opportunity. Shibani will share a screen now.
Hello, everyone. Just starting to share screen now. Okay, I hope my screen is visible.
Yep, Shibani, it's visible.
Okay, good evening, everyone. Welcome to the Mini Bach Harmonizer. This is our final project for MLOps for Univ.AI. Let's get into what we did, the how, the who, and the why, all of it. Let's start. Well, what is our project? Wouldn't you like John Sebastian Bach to jam with you? Well, we would, and that's how we came up with this idea. Before we go any further, what's a melody and what's harmonies? Well, let's start with something simple. That would be our input. What's simpler than this? Sounds familiar. Well, how does that sound with harmonies? Well, as you saw, it makes a world of a difference. It's not just the melody, but also the accompaniments that bring the music alive. As mentioned, the Google's first AI-powered doodle from 2019 is our inspiration, and it's been collecting user data all this while with due consent, of course. Let's get into the how. Well, if both the doodle and our project use CocoNet as the base model, which is the machine learning model we've recreated, what's the unique thing? What's different? Well, the first thing is we're only working with the outputs of the doodle that was originally trained on complex symphonies composed by Bach himself. The second challenge that we made ourselves face quite intentionally was we went ahead and chose only about 1% of the data to work with. We saw a lot of repetition, then we wondered, well, could we use only a fraction of the data and recreate the Bach magic?
Yeah, so let me walk you through our model now. So the basic unit of our model is a fairly straightforward convolutional neural network with batch normalization and residual connections. And we repeat these basic units a number of times, followed by a dense layer at the end. For training, we treated the music for each voice as represented in piano roll, which is nothing but a two-dimensional array with discretized time and pitches. And we stacked these different voices as a convolutional feature map, wherein these voices indicates different channels for these convolutional feature maps. Next, we added one additional channel per voice called mask, which indicates whether the pitch for that voice is known or unknown at that point in time. The resultant 8-channel feature map is then passed to our model, which produces the prediction probability distributions across different pitches over different times for different voices. Initially, we sampled all of the pitches simultaneously, which results in a complete but typically nonsensical score. So we erased some of them and then again passed it through our model, and the whole process repeats again. Through this animation, we can see that over time, we erase and rewrite fewer and fewer notes, enabling the process to settle on a coherent result. Now, let me give you an overview of our technical stack. So while building this app, we got to wear many hats, be it of developer, ML engineer, or ops, and we appreciated how everything comes together in building the final product. So we use TensorFlow for developing our deep learning models and Google Colab for training the models. Docker containers were used to segregate our development environments, and GitHub was used as our source control. Now moving on to the ops side of things, we used Fast API to provide REST interface to our backend and Node.js and JavaScript as our frontend. Final model was deployed on Google Kubernetes Engine, and Nginx server was used as our forward and reverse proxy between the outside world and our frontend. So that was the MLOps for you.
Well, let's move into the who this application really helps or what the applications are. Beyond entertainment, which is a fun interactive tool for everyone, it can also have a two-tier scale. For novice users, they can use open source music, relying on classical music like that of Bach to generate and inspire their own harmonies. For advanced users, we could also eventually have an ability to let them upload their own data and let the AI approximate their particular style. For future scope for us includes two things. Well, we aim to collect user feedback for each run. That's because art is subjective and we'd love to hear what our users say. And secondly, we'd love to extend this input and harmonies to a longer phase, moving into the generative phase, experimenting with generative models perhaps. Well, hearing is believing. So without further ado, let's go to our demo. Here we are. I hope you can see my screen. So this is our web app. As you can see, we have a welcome page with a few simple instructions. All you do is use the cursor to fill in your melody, whether it's soprano, alto, tenor, or bass. Pick your favorite and let the app do the rest. What's more, we have a bonus feature now. If you don't like the sound of our output, you can erase the sections that you don't quite prefer and hit harmonize again and wait for the model to give you yet another result. Well, let's get started. Okay, this is our interface. Don't get confused by the million boxes. It's basically a representation of a piano. So perhaps over here, you have the middle C, and think of these as piano keys moving through time. To give you a certain insight, we give a sample melody right here. Let's hear that. That's simple enough. What happens if I hit harmonize? Bach is getting busy. Well, as you see, the interface is simple enough for a novice user to click around and make a fun melody. It's also intricate enough for somebody who knows a little bit more about music to get a bit granular and change the notes around, change the voice, erase, redo. The solution. The harmony is ready. Let's hear it. Well, that wasn't bad, was it? There's also more features here. You can change the scale you're working with if you're familiar. There's also a save button. I can hit save. Well, yeah, I do trust this website. We can save that MIDI file. And MIDI files are rather robust. They can be converted into any media format. You can change them later on. In fact, just yesterday, we used our model to wish one of our friends happy birthday. I think we have that here. Let's hear that too. Well, there's some room for improvement, but I think that sounded pretty good. Thank you, everyone.
Thank you, Shivani. That was wonderful. Really nice. That happy birthday, a little bit jazzy for me, but that's okay. That's the way to go. Do we have one question? We have time for one or two questions. Don't be shy. No questions? Anyone? Yes, Rish, go ahead, please. Yes.
Hi guys. So I wanted to ask, how are we incorporating the scales and the modes? Suppose I want like Bach and Mixolydian or Aeolian. How are we going to incorporate that?
Well, Rish, the model is up to training with anything you give it. And as a user, if you put in whatever input, it's up to you, right? If you want to limit yourself to the scale that you are referring to, if you want to work with pentatonic notes or minor notes, that's up to you. So if you we'll share the link rather. So if you look at the interface, you can change the scales, you can work in any scale you want. You're only limited by the keys, which makes it in fact easier for you to stick to the key of your song so that you don't accidentally click notes that don't sound good together. But for scales, it's up to you what input you provide.
Okay. One more question. Okay, since nobody's asking, I will ask. First of all, is the URL available to all of us?
Yes, yes, it is.
Yes, Professor, I'm just sharing it. Yes.
Okay. Second is, can this scale? So if you all of a sudden, this becomes the most popular new app after, I don't know, ChatGPT, can this scale up?
Yeah, to answer that, Professor, yes, we have deployed it on a Kubernetes cluster. So for now, we have just kept 2 virtual machines just to take care of the failover part. But going ahead, if we anticipate that, yes, we are going to have more traffic, then we can scale it to more machines.
Okay. And where is it hosted, on GCP or AWS?
On GCP, yes, on Google Kubernetes cluster.
Have you thought about putting this in some kind of a serverless thing? Because, okay, maybe you won't become so popular. Maybe we don't need to have the whole Kubernetes cluster, or we haven't thought about that.
Right now, we haven't thought on that aspect yet. But going ahead, we can see and just pivot accordingly.
Mm-hmm. All right. Thank you, guys. Thank you for a wonderful presentation, I must say.
And Professor, just to add one more thing. So initially you mentioned that the happy birthday was a little jazzy for you. So
yeah.
Now we have incorporated one more functionality in our front end that you can erase some of the parts which you don't like and then reharmonize again, and it will give you another harmony.
Okay, great.
So you can try that out.
So in India, when you have happy birthday, what do you sing? The happy birthday to you, or there's a different song?
Yeah, generally we say, yeah, happy birthday to you. And
it's the Indian version of the original happy birthday song.
It goes faster, right?
I think there's another question from Bridge.
All right, Bridge, go ahead.
Yeah, my question is, like happy birthday is quite simple song, simple tune. You know, in Indian classical music, it is more based on melody. So have you tried any of ragas into this? So like some ragas don't have a fixed scale as well. Which is you can't find the tune, the swara into the keyboard and all, because it is somewhere in shrutis. The line, the sound of that which isn't found in the keyboard or the piano or something.
Yep.
So
yeah. Well, we are limited to what a piano can play, considering we're working with MIDI inputs. So MIDI inputs are usually mapped to every note in a piano or every note in a standard instrument, but you're not limited to notes. The way our UI is designed, if you try it on your end, you'll see that you're limited in terms of note duration. So you're limited to 16th notes. If you wanted something shorter than that, you can't do that. But in terms of notes, you can do any kind of notes. You can do sharps, flats, which in Indian classical music is komal swar. You can put that in as well. So you can do all of those things. So if you wanted, technically, you could put in a raga in there. You'll just have to sit in and integrally, fill in those boxes and know what you're putting in. That's all. But you could put that in. I don't know how that would perform, but that's the beauty of it. It can be trained on any kind of MIDI information you give it. So as long as we're able to convert the audio input to MIDI is rather robust, like I mentioned before. And we didn't even have to work with audio data. It was just text data because MIDI encapsulates that audio information in text.
Yeah, so going ahead, Bridge, right now we have just trained it on the outputs that were available to us from the Google dataset. But going ahead, if it requires, then we can train it on Indian ragas and other stuffs as well. Because we are not limited by the piano, we can change the front end, and also since we are working with the MIDI file, you can always take it to other instrument as well.
Okay.
All right.
So
I think we should move on, right, Bhavna?
yeah. This was a fabulous presentation, guys. Well done. We now move to our second project. It's called Emotion Detection and Analysis, a web application which will create a report for audience reactions to help public speakers improve their speech. I think this is of particular interest to me, given that I'm being brought to the forefront and into the limelight to be doing these sessions. But over to Amir, Himani, Ibtisam, and Rohit.
Thank you, Bhavna and Univ, for giving us this opportunity. And we'll just share our screen and start. You can start.
Hello,
Himani.
everyone. Yeah. Hello, everyone. We are the Mystic Forces. Our team comprises of Amir, Himani, that's me, and Ibtizam. And we bring to you EDA. EDA stands for Emotion Detection and Analysis. Remember the first time you had to give a presentation? Do you remember how nervous you were? Did you shiver with the fear? Did you wish you could read minds just to know what to say to satisfy your audience? Didn't you wish there was an application that could give you statistics about your audience's behavior? Don't you worry, my friend, because your prayers have been answered and EDA is here to your rescue.
So what is EDA and what's our vision? EDA is meant to be a smart web app which could be coupled with our meeting application to gain real-time meeting analysis and receive live feedback in the form of report by taking into consideration facial expressions of the audience and the context of their speech. The models we have used are YOLO. It's our facial emotion recognition model and was trained on subset of EffectNet. Then for speech, we converted it into text using OpenAI's Whisper. For sentiment analysis, we use SentenceBird. And for text stack, we use TensorFlow and PyTorch as our framework. GitHub was used as our source control. We containerized all our apps using Docker. And for communication between these apps, we used Fast API as for developing our RESTful API. Then React was used for our front end. We will be scaling using Kubernetes, and we deployed it on GCP for GCP. These are the libraries we used in our project. The web architecture. The user uploads a video into the front end, and the front end sends it to the preprocessor API. The API splits into two chunks, the audio and the video chunks. The audio chunks are read by Whisper container, which generates text chunks. These text chunks are read by SBird container, and it generates the analysis. These analyses are sent to the GCS bucket. And on the other end, we have video chunks. These are read by GCS bucket and are sent to the YOLO container directly from the GCS bucket. The YOLO container then gives us the video predictions. These predictions are again sent to the GCS bucket, which in turn gives us the final results, which are sent to the React front end, and then it gives it to the user. Now we will go to the EDA demo.
Thank you, Tizam. So now we move to the EDA demo. Now, here we can see this is our web application, EDA, that is Emotion Detection and Analysis. To start analyzing your videos, you just have to go, say, get started, and it will bring you to this section where you just have to input your email and click on choose file to choose whichever video you want an analysis on. Then click open and hit submit. We will be skipping this part because videos take a while to process. Hence, we also have some pre-processed results for you in the My Videos section. So let's go to the My Videos section. And here we can see we have some pre-processed results for you. Let's have a look on this video. So the first thing is the name of the video. And the second is you have a links to the report of the analysis that is generated by EDA. So this video is my guy Tony is here on the top right block, and he is giving an interview, right? So it would have been so wonderful for him if he had these analysis on real time. But anyways, let's see what EDA generated for it. When you click on review results, it will take you to this page, and here are the results. On the top, we have the metadata of the video. Then we come down to image sentiment analysis portion, where on the left, there is a bar graph that shows the frequency of the overall reactions in the entire video. So we have three generic reactions. We have coupled many emotions into these three categories, that is positive, negative, and neutral. On the left-hand side, you can see there's a time series graph that displays the frequency of the reactions received in an interval, and we have chunked the videos in a 10-second interval. So for instance, in the first 10 seconds, how many reactions you received are positive, negative, or neutral. And we can see that John has get the peak results of positive reactions in the 50th to the 60th second. So this will help our user to know what thing have worked for them and what didn't and when. So now moving to a speech sentiment analysis portion. Here we provide you tables that contain the sentences that have received the highest engagement corresponding to their respective classes. For instance, we take positive class here, and in the 50 to 60th second interval time frame, John said this sentence and he received 8 positive reactions from his audience, and this helps him to understand that his interviewers were happy with this sentence and what he said. So these tables can be read in a similar fashion for the other classes like negative and neutral responses as well. And this is basically what EDA generates as a report. So thank you so much. This is our web app, and we are now open for questions. Hello.
All right, thank you, Tim.
Yeah.
Did you ever put any of the lectures through this?
Can you repeat that, Pablo?
Have you ever analyzed any of the lectures of us?
We were thinking like, but the video would have been really big. So we want to scale it. Yeah.
And
That would
be kind of fun.
Professor,
which part did everybody become neutral on?
Say again, Rahul, can you repeat?
Which part did everybody become neutral on? That means everybody went to sleep or something like that.
Professor will let you know once we do that.
Yeah.
We did put a video once of a meeting we had with our Professor Shivas. It's not in the top 3 right now, but we did do that. And it's nice to see.
Yeah, we presented it to Shivas that
But I really think it would be a valuable thing if you move the plugin for Zoom and it gives me warnings. They're falling asleep. Do something. Dance now.
Yes, that is our next step, like to create plugins for the web applications like Zoom, Google Meet, and like Microsoft Teams as well. Yeah.
Are you actually thinking to move it forward and commercialize this?
Yes, maybe. Yeah.
I definitely think we need to look for some VCs for this for this one. I had a question about how so right now, if I understand, the architecture is more along the lines of you submit the entire video with a certain number of frames.
Yes.
And it will do an analysis for you and give you this time series over a series of time. So one question I had was, what is the latency of response on this thing? And if I therefore wanted to sort of like give Pavlos an almost real-time notion of how boring he was, how would I be able to do that?
It actually depends upon the hardware we have. We are running it on GCP, so we are using the highest number of cores we can get there, 24 cores virtual machine. We aren't getting GPUs there, so it takes almost.
Oh, so the inference is all on CPU right now.
Yes. It takes almost 4 minutes or 5 minutes. I mean, it depends upon the video length, actually.
So if those models you have, the Whisper and the Spirit, are they the full-fledged, or are you trying to compress them, distill them by any chance?
No, we haven't performed distillation yet. So they are full-fledged models at the moment. But when we will try to make it real time, so that is where we'll try distillation in them, because they are fairly big models with large number of parameters. And if we have to make it real time, so the model should be less. It should be concise a little than it is already.
Yeah, and mainly YOLO takes some time because it
Yeah.
is predicting on the pictures, but it can do it in real time, but it needs some more fine tuning.
Right. And so, I mean, if I give you a 1 minute video of me, it will take how long?
4-5 minutes at maximum.
Yes.
Okay, so that means that and there is no sort of auto regressive aspect to this, right? In the sense that I could chunk my 1 minute video into 10 6-minute 6-second, or maybe, or is that too little a time to get the emotion out? Or, you know, I'm trying to understand. Could I chunk it into 6 10-minute sections and then set it to 6 different container sets running on Kubernetes somewhere? How would I scale it is what I'm I suppose asking.
It would take your entire video, even if it was 6 or 10 minutes, right? So video chunks will be created right here, and these chunks frame wise will go to GCS bucket, and you do not have to give it to a different set of containers. The one we'll store it in the storage, GCS storage, and from the GCS storage, it will corresponding to the video name or the key that we are providing. YOLO will fetch them and do the analysis right away on the whole video. It does not matter if it is 10 minutes long or 20 minutes long. So we have the chunks, so it will do the analysis on the whole video, and we'll get the result for the whole video.
Got it.
Yeah.
Okay, one more question, not from, by the way, Rahul, your video I can quickly answer. Boring. Questions from anywhere, from anyone else besides me and Rahul? Jess, go ahead, please.
Can you hear me?
Yes.
We can't see you, but we can hear you.
Now?
Yes, perfect.
Yeah, so I had a question. Why are we using text prediction? Isn't this based on the human emotions captured by the camera?
So Ojas, it is on the human facial expressions as well as the sentiment of the text, which the user is speaking. So for example, if this is the meeting going on and I'm speaking at the moment, it will tell you exactly when Himani, you were speaking this sentence, these many people were happy or positive, feeling positive, these many were feeling negative. That is the whole point. So you can tweak it in such a manner that the negative ones go to neutral or to positive.
So let's say I'm speaking a negative sentence and the emotion is also negative, which means my whatever I want to convey is being conveyed, right?
Can you repeat that, Ojas?
So you said we are analyzing the text for the emotion of the text, and also we are recognizing the facial expressions of the people out there.
Yeah.
So we want to check whether what expression that we want to, like what impression we want to have on people is being had on that people or not, right?
Yes.
So are we also providing an analysis of that? Like, are you also providing that?
Yes, I think the tables do that, right? So you let me understand your question properly. So your question is, if you said a negative sentence and it is predicted as negative, so can you see the reactions of the people on that, right? Is that your question?
Yeah. Are the people's reaction in sync with the sentence that I speak?
Yes.
Oh, yeah, that is, like if you have said a sentence in 10 seconds, right? That you are doing this and you've spoken a sentence in a 10-second window, right? So all the reactions are in sync with those like the reports are in sync with that sentence. So we have created the data structure in the backend that way that everything go in sync with the time series we have.
I didn't mean in a way of actually setting the clock. I mean, like I want to have a positive impact on my audience, and is the positive impact being had on the audience, or are you checking that as well? Like, is the purpose of analyzing text that?
So the purpose is to figure out, I mean, we cannot always have positive responses from every meeting, from every sentence. So the point is not for us to convert it to a positive response. It's just showing the analytics so that the user knows when what type of impact it is creating on the audience.
Yes,
Okay, I'm gonna stop you guys there. We need to move on. I know Anshul and Suprit have questions. Do you mind putting your questions on the chat so the team can answer? In the meantime, we go to the third presentation. Sorry about that.
Sure. I'll just stop sharing. Thank you, Pablo.
Thank you.
Thank you, Professor.
All right, so let's go to the third team. But
Yeah.
Pavna, who is the third team?
Well done, team 2.
Yeah,
We have
well
a solo presenter for this one, Project
Oh,
3, Discover the Magic of Reading with Storypal.ai. This app is an innovative tool that uses personalized images to create a unique and engaging storybook experience for children. The presenter is Akshay. Over to you.
Hi, Bana. Thank you for the introduction. I'll get into the presentation right away. Okay. Yeah. A reader lives 1,000 lives before he dies. The man who never reads lives only one. George R.R. Martin. Storypal.ai. Discover the magic of reading with Storypal.ai. I'm presenting an app that I built as part of the Univ.AI's final project. So the problem that we are trying to solve here is the reading among young children is declining. And if you see with the previous generation, the children are spending less time reading, and the enjoyment of reading has also came down. And one of the main reasons for that is the current storytelling technique does not engage or does not excite the children, especially when they have the social medias to work on. So what we are trying to solve here is we are trying to find new ways for us to make the storytelling much more interesting and make the children much more engaging to the stories. So how are we going to do that? We have built an innovative app that uses personalized images to create unique and engaging storybook for the children. So it means that each of the children will have their own storybook, and they will be the character in that. So the parent will be creating the personalized adventure stories for their children. And how they are going to do that is, the parent will provide the images of the child or the child's closest companions, maybe the pet or even the parent himself. And the parent input the prompt, which are used to create a custom illustration for the storybook. And the AI app finally creates the entire storybook with all the illustration, with all the storylines. So let's look at a sample here, which I've taken from one of our storybook. We'll be getting to this soon. So this is my nephew, Appu, playing in the garden with his black puppy. So this is not an image that we have taken in a mobile phone. It's actually an AI generated image. And you can see here, this is a storyline. Appu take good care of the puppy, and the puppy got well soon. The puppy and Appu became very good friends. If you can see here, the storyline and the image generated are inconsistent with each other. So by this, we'll have the entire stories created where the images will resemble the storyline. So what kind of a data that we would need to create such storybook? So we would need personal data with different and diverse background. So this is the images of my nephew. Here, if you can see, the most of the images are taken from mobile phone. And what I've observed while training this is that it doesn't actually matter if we have a different background, as long as we have images with different poses, it will give good enough result. So let's look at the model. What kind of model that we have used to create these images? So we have used the stable diffusion model along with the fine-tuning method called Dreamwood, which is something that is released by Google on August 2022. So what is stable diffusion? So stable diffusion is a text-to-image latent diffusion model which generates images. So it consists of majorly three parts. One is a text encoder. The other is an image information creator with a unit and a scheduler. The unit is a convolutional layers with skip connection. And then you have an image decoder. We are looking at stable diffusion during the inference. So look at here, the Paradise Cosmic Beach. So this is the prompt that we are passing, and that would be passed into text encoder, which will be converting that into token embeddings, and which will be an input to the diffusion model along with a random image information tensor. This will be an 32 cross 32 tensor. Both of them will be used as input to the diffusion model. The output would be again a 32 into 32 image embedding, which would be passed into the image decoder to generate the image. Now, if you look at the end, the prompt that we have passed and the image that we have created will be consistent with each other. So in the previous case, you saw that the Appu playing the garden. The prompt for that was Appu playing with a black puppy. That was the prompt, and you saw the image generated. So this is how we generate the images. So so let's look at the flow from an user perspective. So the user would provide the images. It can be of the child, it can be of the pet, it can be of the parent himself, because the child connects with his closest companions. So the other input that the parent would have to give is the story outline and the prompt for illustration. The prompts along with the images goes into the stable diffusion model to generate the illustration. And the illustration and the story outline will be used by the app to create the storybook. So let's look at the demo now. So yeah, so let's look at the story that we have gone through now. So this is the story that I've shown you earlier, where the Appu is playing in the garden, and then Appu one day finds an injured black puppy, and Appu became very good friends with the black puppy. And then Appu one day fell into a deep hole, and as you guessed it, the black puppy came to his rescue. And I've shown this, I've shared the story with my sister, and she showed this to his son. So he found this story much more engaging, and he wanted the story to go on, and he was inquiring about the black puppy more and more. But again, while at the beginning, I thought all the stories can be of the children. But when I showed this, my nephew liked the story of Me the Best, his favorite uncle, and I'll take a stroll through that as well. So if you see here, this is the king, me, sitting in a throne, and the god Fortuna gave me a wish that was whatever that I touched would turn into pure gold. And the king Akshay turned arrogant, touching everything into pure gold. And soon, but he realized when he was hungry, he took an apple in his hand and it turned into pure gold. And Akshay cried, this was not a blessing after all. So, this is so that gave us the inspiration to create images not only of the children but also of the parent, favorite uncles. And this is an story that we created of the pet that we have. Now, so we can see here we can create storybooks based on children, adults, and pets. So how is a new story created? So you can see here the parent. So this is a dashboard how it would look like to a user. The parent can see the storyline, that is a storyboard that is created here. And if he wants to create a new story, he can go and click on the plus button, and then he can give the details here. So rather than this, let's look at the already generated image. So this is how the user would be giving. The user would be giving the title here, Appu's Hero, and the title prompt. This prompt would be used by the stable diffusion model to generate the images. And the parent can select any of these images, which will automatically update at the backend, and we can see in the storybook with these images. And so one thing that we have to note here is the story outline and the prompt. The prompt is actually an extension of the storyline. It's inspired by the storyline, and this prompt will be used to generate the images. So this makes sure that the generated images and the storyline are consistent with each other. And once these details are given, we have options to give 5 story lines, and then the parent can give the character name, in this case Appu, in my case Akshay, and the character classes, since Appu is a child, the character class is child. In my case, it's person, male adult, and this is the style that we can give. We can give a digital artist style, or we can give that the king should look like the Egyptian king. These are the prompt style we can use, and we click on save. So you can see the images changed here. And okay, now coming back to the presentation. So this is the first user interview that we have conducted. And this is my nephew trying out the this thing. And just to make him more happy, this is upcoming stories for my nephew. Me as a pirate of the Arabian Sea, as a race car driver and the astronaut. The idea behind this story is that when someone asks him who's his hero, he'll not say some random Iron Man or Batman, but instead his favorite uncle. Thank you everyone for watching.
Okay, Your Highness Akshay, would you mind answering some questions?
Yeah, sure.
Okay. All right, one question because we're running a little bit late. I see multiple hands. Let's give the chance to Supreet.
Hello.
Hi, I can hear you.
Yeah. So my question was for Hermano, and this is an file for the field and the process some images from a study.
We are not clear, unfortunately.
Error. You want to
Can you mind saying?
Supreet, your audio is a little bit mumbled. Can you maybe?
Hello?
Yeah.
I can hear you. Yeah.
Yeah. So my question was, how many images are needed for the AI to get trained and then generate images for the story?
So minimum 10 to 15 images is fine. But when we have at least 25, we'll get more better results.
Okay. Thank you.
Yeah, sure.
All right. I think
Just a quick follow-up to that. How do you manage consistency of your image between the various frames of the story, so that it doesn't suddenly make you look like Pavlos in the second frame?
So one thing is we'll have a consistent prompt style. That is one thing. For all the images that is created in the story outline, the consistent style will be there for the prompt. The second thing, one of the reasons we're giving 3 images is that for that it will be more in sync. But having the prompt style consistent with all the storyline will ensure that it syncs with each other. Did I answer your question?
Yeah, I think so. Yeah.
Shibani, you had your hand up. Do you want to? No. Okay. So, Your Highness, that was a wonderful presentation and a lot of fun. Do we have a URL we can try too? I want to be the king.
So, I'm trying that because the GPU takes I have to. It's very costly. So that what I do now is I get it the images and then I train it in Google Pro and then this thing. So I'm trying to make it more live so that users can commit and train it and then see it.
Okay. But
so I think I'll be working on this again. So I'll share that with you.
Okay, thank you. All right, thank you. That was wonderful too. Nice transitions, nice story. All right, let's move to the next one, right?
Okay, bringing in Mahima, Rafi, Karthika, and Aman. They'll be presenting QHunt, AI-powered semantic search for academia, a semantically aware search engine that uses fine-tuned cybert for word embeddings and perform locally sensitive hashing to speed up the extraction of desired paper details with a given query. Over to you guys.
Thank you, Bhavana.
Thank you.
So greetings everyone. Now about QHunt search engine
Hold
for
on.
an AI enthusiast.
Can
Hello?
you hold a minute? Your audio is not the best. Is that just me or?
No, it isn't all right.
Yeah, it's the internet.
Maybe someone else can start from the team.
Or Karthika, you can just try switching off your video. That might help.
Yeah. Okay. Is it audible now?
The
Yes.
hard is yes.
Okay. So the ultimate search engine for an AI enthusiast would exactly understand what you mean and would give back exactly what you want. So that is our project, QHunt, a semantic search engine using locality sensitive hashing. Now we'll be seeing the problem definition. That is, we want to showcase the effectiveness of semantic search engine over the normal keyword-based search engine. So semantics means basically understanding the meaning of the word. For example, when we enter a query, father in a search engine, it fetches the results only containing the exact keyword father. But in the case of semantic search, it thinks like a real person. It fetches all the synonyms, that is, father means dad, papa, or it fetches all the relevant results, even though if we don't include the initial keyword. So the main objective of our project is to assist the AI enthusiast in getting all the relevant research works by understanding the user's in conceptual meaning and the context of the user's query. Now, the proposed solution. Our proposed solution is creating an academic domain-based vector search engine, which gives us an improved search result by understanding the concept and conceptual meaning and the context of the user's query to find the similar output. Now we'll be seeing how it can help. It is helpful for researchers who is working mainly in the AI domain, AI enthusiastic, to check the novelty of their ideas for the initial stage of idea formulation. Also, it is useful for AI-based literature surveys. Semantic search allows you to buy back your valuable time. Otherwise, that would be spent on reading a huge amount of research papers. The dataset that we have used are all neural IPS paper, which is a conference and workshop held every year, and we have used the archive dataset.
So the model we use is BERT Mouse language model, apart from BERT NER or BERT classifier. The reason behind that is the mouse inputs are given and it has to predict the mouse inputs. So how is it helping us is it's understanding the context among the words and its multiple representations. And one of the advantages of using this model is it aids in next sentence prediction. So this can be useful in next text generation when the user is typing in the query. So for the fine-tuning purposes, we have used Scibert pre-trained weights. So Scibert is a scientific bird which is trained on huge corpus of scientific data. So we have to downstream this to AI-specific tasks to have fine-tuned based on our dataset. And then we have pre-processed on Scibert tokenizer. So this is the loss graph on fine-tuning. We could say that after certain epochs, it's overfitting. So to avoid that, we have taken previous checkpoints, like around 8 or 9, so that the model doesn't overfit or memorize.
Yeah, after converting all the headings like titles to embeddings, we will store these embeddings in a database. So, but our key constraint is we have to fetch the data within seconds or milliseconds to show to the users or our customers. So for that, to achieve that, what we had done is we had used an algorithmic technique called locality sensitive hashing. So the intuition behind this locality sensitive hashing is, so we have a data and we have to group the data based on the similarity and store those groups in a backend or in a database. When we get a query from the users, we analyze the query and then we will find out which group it belongs to, and we will go to the database and we'll fetch that particular group, and within that group we will find a more similar documents or research papers to showcase to our users based on the similarity.
Okay, now that we have the same things in parts, let's get it together. So we have used 2 data sets and we have trained a model and validated using neural IPS, and we have generated embeddings for both the data sets. And these embeddings are the input for LSS model. We have trained on that. And the hash tables are stored in Google Bucket. So when the user types in the query, it's converted to an embedding and the vector-based LSS search is performed and top 5 out of 10 results are given out. So now, before going to demo, few things to see is, this is the graph which shows time taken on query search. So that is before LSS, it was 12 seconds on query search, and after LSS, it's 1 second. That is significant considering 30K data points. There is an ambiguity in natural language. One is called polysemy, which says that a single word has 2 different meanings. That is apple as an iPhone and apple as a fruit. And another thing is metaphor, wherein 2 different words have similar meanings and they're anonyms. That is ontology and knowledge representation in graph database. This is one thing to consider. And another thing is, we could say just include your NER model in query filtering. It eases the task, it increases the accuracy. Like example, pens by Pavlos. Filter out pens and search for the pens, and sorted by the author Pavlos. But there is a catch here. What if the input is Fisher GANs, which is a kind of a GAN, and we did not filter out Fisher from this? So this is one of the reasons we haven't used NER in query filtering. Now let's go to the demo.
Just a second. I guess you can see my screen.
Aman is not sharing. He says Aman Jolie has started screen sharing. There may be a button on the top which looks orange. You have to click the go button.
Oh, it's
I guess it is. Okay, so this is the front end, and this is the live demo of the QHunt app, the semantic search engine. So let's try a simple query, backpropagation. So as you can see, we are getting some relevant results: Laplace propagation, Brown propagation, and we have also added link to DOI so that user can scroll to that relevant research article. Also, let's try something else. Instead of backpropagation, let's try backtracking. So contextually, both are same in AI. So you can see, apart from this above dynamic backtracking, results are almost the same. It means our model is intelligent enough to figure out that backpropagation and backtracking are literally the same thing. Now, let's try some other things. Let's try ontology. So as you have seen in the example, ontology is equivalent to knowledge representation or graphical database. We are getting a paper title, knowledge representation. So this type of results is pretty much making sense. Now let's try some bigger sentences. If you can see this, I have this paper title, robust kernel bias aware prediction under covariant shift. So let's just try to see. So this is the exact paper title. And the best part is we have trained our data set on abstract, not on title, but still it is giving us the top results. Now let's just try to rephrase it. So we are using this paraphrasing tool called Quillbot. Just a second. Yeah. So it has paraphrased it. Let's just paraphrase it more. I will change shift to displacement, prediction to inference, and maybe robust to strong. Let's just try. Okay, the results are changed, but still at okay, still we are getting some relevant result, the relevant title. So it is making sense, although the ranking has been decreased, but it is making sense. So our future work would be adding a spelling rectification module and adding a word suggestion module while typing of the query. And we want to make this approach memory optimized. Moreover, we would like to add document similarity module so that we can make a semantic based plagiarism checker. That's all from my side. I hope you can see it. Yeah, thank you.
Are we done? Yeah. All right, thank you very much. We have time for one or two questions. I see a lot of clapping. Ignacio is waving his physical hand. I guess he wants to ask a question, right? Ignacio, go ahead.
I'm an old school guy. A fantastic presentation, really interesting work. I see it works, so that's fantastic. Now, usually when like I am looking for a paper or throwing ideas, I don't type like a coherent phrase, but I throw in like related words to my query. So my question is, in that setting, how does the model works? Can you get like relevant results, or the model is having like more problems?
Can you be specific on what kind of input you would be providing?
For example, I'm looking for, let's say, a model based on transformers that it's then using an RNN. So I will throw into the search bar RNN, BERT, machine learning, just to be sure. So
Yes.
can the model adapt?
Yes, we have tried these things on, especially when the prepositions goes in like off, then I think the model is going nuts. It's like, it's not showing the accurate results, but when you're given the main words, like model transformer or something like that, it gives you the results, necessary results. But the moment certain things like I think, or how is this, those kind of words go in, it's not gripping the good results for us. So we have to improvise that to acquire that generality of when the user talks in the normal way. How is it? How is that? What if? This is the thing we have to incorporate.
Good. And my last question is regarding like future work. Are you planning on like keep developing this? Because what would you do like in order to improve the user experience? For example, some kind of ranking, sorting. How would you improve the transparency of your solution?
In the future, we would add in various sorting based on authors, titles, or any time zone like year. So we are thinking of adding those. And is anyone else want to add up to this?
Yeah, I mean, as far as this front end is considered, we can add certain filters. We actually need to add those filters. So that search can be filtered as per year, search can be filtered as per titles, search can be filtered as per citations, number of citations. So yes, we are going to add that.
Fantastic.
All right, thanks everyone. So again, I'm cutting a little bit short because I want to be wrapping up on almost in time. So we have one final presentation, Bhavna, is that right?
Yes. Coming to the last presentation of the day by Himanshu, Saurabh, and Ayush. It's called Find Spine App, a tool to help doctors and technicians detect spine fractures, and a web application intended to assist doctors and technicians detect spine fractures in patients.
Hi everyone, I'll be sharing my screen. I hope it's visible. Okay, Ayush, you can start.
Good evening, everyone. Me, along with my team, Find Spine, are going to present our project on cervical spine fracture detection. Next slide. So first things first, let's talk about data science in healthcare in general. Data science is used in multiple domains in healthcare, like drug discovery, for the synthesis of new drugs using AI, for chatbot assistance, and for live data tracking and handling huge amounts of data. With the help of the application of data science, it has now become possible to detect symptoms of a disease at a very early stage. Also, with the advent of various innovative tools and technologies, doctors are able to monitor patients' conditions from remote locations as well. It can also be used for predictive imaging by learning disease patterns, which is related to our particular use case. Next slide. So to talk about our problem specifically, there are 1.5 million fractures that occur annually, and that is only in the US, of which 15% are in the cervical spine region, making it the third most common traumatic injury in elderly people. Next slide. So what is the cervical spine? As you all know, the human spine is made up of 33 bones called vertebrae and has 5 major regions, namely cervical, thoracic, lumbar, sacral, and the coccyx region. Of these, the cervical spine consists of the 7 top vertebrae which support the head and the neck. Next slide. So how can we inspect the cervical spine in the event that there actually is a fracture? The solution is through medical imaging. Medical imaging is nothing but creating visual representations of certain relevant systems of the body. It includes types like MRI, CT, ultrasound, and X-ray. Of these, the CT scan is considered to be the most informative as it combines a series of X-rays along multiple cross-sections, as will be shown later, to better focus at the area of concern. I'd like Saurabh to continue.
Thank you, Ash. So to give you an overview of our approach, let's start with the data. Our data consists of 2019 CT scans obtained from the Kaggle RSNA challenge. Data from the CT scans were extracted in 2 formats. The first is a DICOM file and the second as a NIFTY file. These formats can be considered as normal images, just with patient data such as name, age, gender, study details such as the name of the physician, the time of the study, as well as the device details such as the name, manufacturer, and scanner details. The primary distinction between these 2 file formats is that DICOM file stores images in a 2D format with multiple slices, whereas NIFTY files are stored as a single 3D image. Furthermore, we have observed that NIFTY files capture bone density better, but due to the lack of data, we chose to stick to DICOM files for our use case. As shown on the left graph, our data is fairly balanced for identifying spine fractures as a whole, but is severely unbalanced for classifying individual fractured vertebrae, as shown in the right. So how would our app work? Assume a patient comes in for a CT scan. The machine would scan the patient's spine on the axial plane, as depicted in the video. From the scan, we get the DICOM slices, and we would then concatenate and transform them to create the patient's cervical spine in 2D format. This 2D format image is then fed to a convolution network architecture, which predicts whether the patient's cervical spine is fractured or not. So let's get on to our results. We tested a number of custom and pre-trained CNN architectures to predict the fracture. We zeroed in and built our application using the ExceptionNet model architecture because it provided the best prediction with consistency and good model explainability, which we'll see in our app demo. Over to Himanshu for the app demonstration.
So the Find Spine app is made using React as a front end to make it more interactive, and Fast API for backend because it is a Python-based framework and our model can be easily integrated in it. And we have used GCP, Google Kubernetes cluster to make it more scalable. We have done the whole deployment using Ansible, as we don't have to go to GCP website and provision all the compute and storage. Ansible does the job for us. Enough of this. Let's go towards the app. So as you can see, this is the upload page. I'll be uploading a scan. So I'll choose a scan, open it, and I'll give it a patient ID. Let's say 222 and submit it. So it may take a while to submit. While it is submitting, let me explain to you like how the process works, like how from front end to back end to Google storage the file goes. So first of all, as you click on the submit button, the back end fetches both the patient ID as well as the file. And after fetching both of these, it takes the zip file and extracts it. After extracting the zip file, it will contain all the segments of the images. So your scan has a lot of segments and convert those segments into a sagittal view of image. And then this sagittal view of image is then passed to the Google storage, which is Google Cloud Bucket, and stored with the same name as the patient ID. So in this case, it will be 2222. As you can see, the file is being successfully processed and uploaded. Let's go for prediction. So let me put the number 2222 and submit it. So again, here what happens is the backend is taking the number 2222 and searching it in the GCP storage. And if it gets the image, and so it fetches the image, and then it passes that image through our CNN model. Now, instead of giving the fracture probability, what we are giving is these boundaries. So these boundaries are actually heat maps boundaries, which shows the most likely fracture area. So this, and we are not providing any density of color so that it will help radiologists to view it. So guys, what we have here is an app which helps the radiologists to detect cervical spine fracture. And in case you have a lot of files, let's say thousands of scans, it can help prioritize which patients have severe fracture compared to which don't have. With this, I would like to stop my presentation. Thanks a lot. And if you have any questions, feel free to ask.
All right. Thank you, Tim. This is fantastic and useful. Let's ask a few questions. I see Supreet. You have your hand up. Go ahead.
So my question was, how accurate is your app? Have you tried with any other CT scans to see its accuracy and then took a professional advice to see its accuracy?
Yeah, if I can take over. So we did experiment with a lot of architectures, and right now, even if you see our model results, it's not the perfect one. I would not say it's the best yet, because we did participate in the Kaggle competition itself. We are nowhere in the top hundreds itself. The best architectures are quite complex, using multiple approaches. Now, this would be something that we will work on, like fine-tune the model, use different architectures using, because like I told you, Nifty files and DICOM files. Nifty files are you can get a very accurate representation of a bone. Right now, if you see our explainability, you can see muscles and all other ligaments as well. Nifty files will give you that proper bone, the scan. But due to the lack of data, we weren't able to do that. And getting medical images is quite difficult.
Okay.
Also, to add to Saurabh's answer, we also saw a lot of approaches which uses MONAI and other transformations for masking bone and all, but those things were not implementable in our backend because the file was very huge. So to make it edge friendly, we went with simple models for now. And we, in future, we have thought of incorporating them, but again, those seems a very like a far stretch for us right now.
Oh, okay. Thank you.
I had a follow-up on that, Saurabh. So you said the accuracy, based on the accuracy, it kind of shows those lines, right? So what was the cutoff or the threshold you put?
For the explainability, the cutoff is quite high. Like we keep it somewhere in the 90s itself.
Okay. No, the
yeah.
reason I was asking that was that could answer like Supreet's question is if I had a way to change that to like say 99%, then it becomes very specific, right? So that like that's something maybe you can change or
and additionally we only like it's an active choice that we haven't given a prediction whether it's a fracture or not, because we don't aim to replace the doctor. We just provide you the explainable region so that then they can actually see the image and decipher is it a fracture or not.
All right.
Okay.
Thank you.
All right. Well,
Shivas.
No, one more question I was thinking was you told us about the size of files. So, and I know you're thinking about future work. So have you considered rather than the upload, like direct integrations with these MRI software systems? Because these files I know can go to like gigabytes, right? So like a direct connection and then maybe pre-process at source and then only send something what your model needs or something like that, right?
Yes, exactly. Like the data right now that we have used is around 300 GB and it was only like 2000 patient scans. So yeah, each file is around 300 MB. That's why our upload also takes time. But yes, this is actually a good way that we can upload it from the source itself. Like everything could be like a hospital application that the hospital can then use to upload as well as predict.
Yeah, thank you, guys. I think this is a good segue to just put some final thoughts in the sense that it's not always about the accuracy of the model, it's the usability too. Something we at Univ.AI we're trying to do is, first of all, you understand the models all the way to the bottom, but you're able to deploy them. And I think that the final presentation showed that it's not only about Kaggle competitions and getting the good accuracy and the good score. It's just, can you make this into something that is useful? Actually, a study recently, when Shivas and I put this course together, shows that only 10% of AI is ever been seen by a user, and that's one of our goals here. I think we have seen kind of the diversity of the projects we have from the students, from, I don't know, music to storytelling to spine detection to search engines. This is quite diverse, but I think the theme is there. Can we understand the models? Can we go down deep into the mathematical understanding of the models, put it together, test it, and then deploy it? And I think that's a good opportunity to wrap up the session today.